Good morning. Thanks for hanging in there with us. We had a couple little technical difficulties, which if you think about this for the 10th one, that's not too bad. It's the first time we had a little glitch going on. It is definitely a crazy day for crazy meter installations. So, and it's already started crazy for us. So everybody just tell Mullins to stay calm. We're not going to blow anything up, but if we do, I'll drop and roll. Won't be the first time. So what we're doing is we're back in the series again, our COVID series. Today we're doing the crazy meters. Next week we've got non-Blondell on Tuesday, which is going to be awful interesting because we're going to show some real funky stuff up there. These are recommendations from customers, just like today is recommendations from customers. They wanted to see this. So we are actually instituting, like we say, suggestions you guys give us. So please do that because we love it. So that's what today is, and that's what Tuesday is. And then on next Thursday, we're going to talk about the 4 series. We'll have one of our new salesmen in here doing that. Jeremiah Swan is going to be demonstrating the 4 series. And what we're going to talk about today, like we said, we're going to get a little crazy. So we're going to put a 2S in a 1S socket. We're going to put a 12S in a 2S socket. We're going to put a 2S in a 12S socket, a 12S in a, oh, we got them all, 3S, 9S, anyway, you see them. So we're just, and here's where, and I guess I'm going to say this is just an overview. You know, we talk a lot about, you guys heard me say this in the field, how much I'm a big fan of customer load testing. Well, you'll notice as they're swapping these meters out, we're going to go through these, and that's why, like I said, the customer load test. If you pulled, think about it, if you pulled the meter and stuck it in one of our 4 series and ran a test, it would test fine. If you took it in and put it in one of your test boards in the shop, it would work fine. Then you bring it out here and you stick it in the wrong socket, you got a problem. But a phantom load test wouldn't tell you that on just that meter. Okay? So even if you're out there and isolate it and ran it through it, it wouldn't. So this is where that's why we're big fans of the customer load test, not only for customer complaints, where you can show them date and time that we were there, and you can also tell them we ran with your load, what's going on behind the wall there. We didn't put it in some magic box here with our own load box. So that's the reason why we're big fans of that. You're going to see that here today, that if you actually look and go through the customer load test, we're going to see the issues and the problems we have, okay? So let's go to the first one. We're going to talk about a 2S and a 1S socket, okay? So you ready to go, Mullins?
Yes, sir.
Start test. All right. So you can see here, that's what we've got. We've got a 2S meter, and we've got this socket set up as 1S socket. So what we're going to do is we're going to come over here. I'm going to hold this up here in a second, but first thing I'm going to do is I'm going to go over to my equipment here, and I'm going to say, I'm going to hit my vector button to look at the vectors. There's the vector that we see. Now, you have to remember, there's going to be a difference with what the PowerMaster sees and then when you actually get ready to start running the tests, okay? It's going to set up its reference voltage right here. When we start running the tests is when you're going to start seeing the wonky stuff going, okay? Let's go ahead and do that.
So just to be clear, what we've got is a 2S meter and a 1S socket. So when the PowerMaster is hooked up to the service, it's actually measuring what's flowing through the 1S socket, which should be correct. The rub is when we start doing a meter test and trying to allow the meter to calculate kW when the service type may be incorrect.
No, this is a 2-man job, Mullins. But did I get a pulse? And what am I going to get another one? Are you tilting it either way when you do it? Grab a snake. I'll keep playing with it.
Well, I guess we're not able to get the pulses out, but what would, in the chat area, what would you guys expect the registration to be when it runs, when we do get a pulse out of it?
Brett says 50%.
Britt, you are exactly correct. Why would we get 50% registration?
Get it.
If you think about what's in a 1S socket, you've only got one potential and one neutral. So you've got 120 volts coming into the meter, phase to neutral. So what does a 2S meter expect? It expects to measure phase to phase, which is voltage A to B, and therefore we're only calculating half the 2S meter is expecting a 240 volts, but we're only getting a 120 volt input into the meter. And that's exactly what happens. Registration, you get exactly what happens. Yeah, good job, Brent. Okay, we're gonna move. We're already moving, John. So the next one we're gonna be working on is we're going to be moving to a 2S socket, but we're gonna put a 12S meter in. So hang tight. S meter and 2S socket.
Okay.
Go ahead and start.
Yep. Oh, my bad. I'm going to go to a 12S.
Yeah, so John
test.
is selecting a, you're going to do 2S, you're going to do a 2S service. John's going to be selecting a 2S service with a 12S meter inserted. So typically what kind of service type does a 12S accommodate? You can, two different ways, what I've seen before. Most of the ones I've seen before are a 3-phase network, which a network is a lot like a 4-wire Y, but you're only using the A and B elements. So you have A, B at 120 degree spacing, but if you put that into a 2S socket, you've got two potentials that are 180 degrees apart from each other, so it mathematically calculates to a 240 volt. So let's see what actually happens when the meter socket itself is looking for a phase-to-phase reference, but my 12S meter is looking for a phase-to-neutral reference. Go to that camera.
The meter's not powering up.
So what happened now that I'm driving a load? I've got a 12S meter plugged in a 2S socket. What's going on? Why am I not powered up? The reason why I'm not powered up is because I have no neutral reference. So the 12S meter cannot power up without a I think this was an auto ranging meter, but I think it requires a 120 phase to neutral. So if I'm not seeing anything below that, then the meter cannot power up. Therefore, you cannot get a meter test. You can verify the socket is good. You know, with the PowerMaster, I've got my voltages hooked up, I've got my currents hooked up, so I can see everything flowing through the socket. But unfortunately, this meter form is not designed for this socket. So if you have someone who's setting meters, maybe a new guy, an apprentice, or possibly a contractor plugging into this meter, they should theoretically realize that the meter never powers up, and so therefore they should be able to call the metering supervisor to find out what's going on. And so you can quickly see, oh, well, you've got the wrong meter in the wrong socket.
You get no voltage, right?
No voltage, yeah.
That's right.
Okay. Next one, we are moving to putting a 2S meter in a 12S socket. This is a very common occurrence. We've actually had a customer request to see this, and I think this is a good example.
Want to use this one? Or you want to use this one? This one? Tell me. We got two 2S's. Which one do you want to use? This one? Okay. Move it over here.
So John right now is moving his connections over to the 12S socket. Tom actually asked for this in the chat. Tom B asked, how about a 2S and a 12S socket? Well, Tom, we actually have.
Yeah, Jim down in Florida told us that they get big apartment complexes down there, and what happens is that they'll put in their 12S meters and they'll run out of 12s, so they'll just throw some 2S's in there and they'll say, yeah, we're gonna come back to that. But then it takes a long time for them to get back to that, and Jim said it'd be a good idea to show what happens in the meantime when they got the 2S and the 12S.
Let's start.
Okay, so we will hit our there's the vectors. So we don't see anything funky yet. Find a blue snake. Mullins with the magic touch. So as Mullins said before, we talked about the difference between expecting phase-to-phase versus phase-to-neutral. Let me grab a blue snake, man. Grab a blue snake. If I had. Let's see. Blue snake. Got it? Okay.
All right, I'm having to switch back over to the bench and the mic. So we got a pretty crappy registration result. Last time we were testing it, it's kind of random how the registration results come out. We were testing before earlier and we got like 1,000%. But there are a couple reasons as to why. This is what would throw off a new guy or an apprentice or a contractor. If he plugs this meter into the socket, he sees it powers up. He says, "Oh, that looks good. It's powered up. I can head to the shop." Not true until you actually do a test. So there are two things going on with this 2S meter. First of all, a 12S meter expects a voltage reference from phase to neutral. The 2S meter references once a reference between A and B to get that 240 volts. That's problem number one. Problem number two is, what about the current? So because a 2S meter is one of those non-Blondel meters, and quick fact, the 2S is the most popular non-Blondel meter. I don't think people realize that. But with a non-Blondel meter, two potentials do not equal one. It only is on a 2S meter, two potentials and one current. That does not satisfy Blondel's rule. So with the two currents there are two independent currents, but the meter only measures it as one, so it has to shift the phase of the B element 180 out. That's problem number two. So I've got a phase-to-phase reference that's not there, and I've got the meter expects to see the second current 180 out, and that's not there either. Therefore, your registration will be way off. And the mistake would be, again, contractor comes to there, sets the meter, sees the meter is powered on, he takes off. Or let's say you get a trouble call, the customer calls the next month and said the bill is out of line. You take that meter, plug that into your test board, the meter's going to look good. That's the problem. When you stick it back in the socket, you understand, oh, well, wrong socket. Okay.
So now we will transition from the self-contained bench over to the transformer rated bench. So just give us a couple minutes. We're going to reset up over here on the other bench and go over the 12S and the 3S, 9S, 5S, 6S, 9, 9, and 6. All right? Okay.
Yeah, so hang tight, everyone. We're going to be switching over from the self-contained bench to our transformer rated bench. So on the transformer rated bench, we're going to be doing 4 examples on this one. The first one is we're going to insert a 12S meter in a 3S socket. Believe it or not, the the socket actually accommodates a 12S meter and a 3S socket, so it's possible they can actually insert this, and we'll kind of see what happens there. The next one we're going to run is a 9S in a 5S socket. Believe it or not, it does happen. Once you look at it and realize, you kind of slap your head as to why somebody would do this, because it's kind of obvious once you look at the back of a 9S meter why it doesn't work, but we'll discuss that one as well. More common I've seen before is when a customer using a 6S meter and plugging that into a 9S socket, and vice versa, plugging a 9S meter in a 6S socket. Not uncommon when you're out there going and swapping meters. When you have a meter issue, they swap out. Typically, most guys are going to have a 9S meter on the truck, but not a lot of technicians carry 36S or a 6S meter with them. So that may run into a problem. And hopefully when I'm talking about these things, they're kind of running through your head as to what you expect to happen. The hard part is, though, you can't just set the meter, see the light power up, and then move on. You got to be able to verify that it's actually correct. As we showed with that 2S meter and the 12S socket, you can tell that the meter is actually turning. So not only do you have a display on, but you've got positive kW totally throws off somebody who's new to metering. They just think it's their job's done and they can move on. This is a 3S socket, and I've got my potential here. Notice that I want everybody to be clear when we see that potential is here. Testing. Okay. So what I was showing, I apologize, my mic went out. So what I was showing was a 3S socket, and we're plugging in a 12S meter. The 12S configuration, depending on the technical backup. If you notice in the 12S configuration, we have this 90-degree stab here that can pick up a reference. You also have that in this particular 3S socket as well. So if I stick this meter back.
Yep. Yep.
So I put the 12S meter back in the 3S socket, and I'm going to run it.
I'm going to use mine. Use mine? I'm good? Okay.
Yeah.
No problem. This has been my experience. It's always good to get the brains of the operation. Mic check. One more time.
Mic check.
There you go. Perfect.
All right, guys. Not a great day for us technical-wise, is it? I guess that kind of makes sense with crazy meter and mix-up. We have
That's
crazy.
exactly right. Crazy day.
Crazy day. All right, so I've got this meter socket is now powered up. And notice that I have no potential on the meter. Meter doesn't power up. Why doesn't the meter power up? Some of those who didn't hear it when I had my mic was off, notice that this potential here does not line up with a 12S meter. Therefore, the 12S has no phase or no voltage reference, so it cannot power up. That's why. Fairly easy. And again, this should trigger someone quick response if they do set the meter incorrectly. They'll come back and realize that the meter's not powered up, and therefore they'll move on to the next one. Okay, that was it for that one. Now we're going to move on to a 9S and a 5S socket. And I want to, and John, let's show a 9S meter real quick. Show the back of a 9S meter.
Now, you don't have to be the sharpest pencil in the can to see. I've got all of these stabs right here, but look at my socket. There's nothing here, right? Can you see that? You can see you got all these stabs, but there's nowhere for them to land in the 5S socket. So there's no way in the world that's going to work, right?
So do we expect this meter to power up, yes or no? The answer is no.
Yeah, I'm making up.
But believe it or not, it has happened. A guy will stick that in because it will fit. A 9S meter will fit in a 5S socket, with John proving that.
There it is.
It fits in there, but it will never. You will never get the meter to power up because there is no potential stab. The actual potentials, flip the 9S around again. The potentials on a 5S meter are going to be these independent ones. So you got a potential here, and then a 5S is a potential here, and that's where you get your voltage and the currents on the outside. So it would never work as far as a configuration goes. Easy one, but it's common more than you think. Next one we're going to be doing is a 6S and a 9S socket. So we're going to use up that 36S. Mount that camera over there.
So it's a 6 and a 9, so we're going to go to a 9 test.
So what's the main difference between a 6S meter and a 9S meter? What's the main difference, I should say? Main difference is that there is no B-phase potential, right? You ever heard the term 2.5 element meter? That's in reference to a 6S meter. It actually accommodates missing a voltage transformer. So back in the day when engineers would, and I apologize to engineers who are listening right now, but back in the day, engineers who were budget conscious and wanted to try to save a few dollars, they came up with the idea of, well, I've got a 4-wire Y service, but I can save a little bit of money if I remove the B-phase PT. So that came up with an interesting issue for the meter manufacturers to accommodate that, to make it work. Again, this is an example of a non-Blondel meter, and if you guys stick around, next Tuesday, we're going to go into this in more detail. So if you look at the vector diagram, you'll notice that we've got all kinds of phase reference problems. So on the back of a 9S meter, you've got the A, B, C potential, then you've got a K, Y, Z that goes on, and then that goes back to a neutral reference at the very, very end. On a 6S meter, there is no B potential, and so the 9S socket actually sees that 36S as one of the, I think it's the Y, the K, Y, Z, so it has no potential. So therefore, it has no correct phase reference, so that's why you see your C lined up with the B phase potential. Let's run a meter test, see how that looks. Sure. So we're running a customer load meter test. Just watch your feet.
Oh, yeah. So the lock is right. I did
So if you're looking at the PowerMaster, notice that this particular service type is expecting to see a voltage. And like I mentioned, when you plug in a 6S meter to a 9S socket, the potential references get shifted over because that potential B is no longer there. So it sees it as a C phase voltage. So be aware of that. Don't let it throw you off. But we're going to go ahead and click on ignore and then run the test anyway. Notice it does get pulses. It is calculating kW. I doubt it's right. So you can see our registration is way off. Two big reasons. The 9S service is expecting to see a B phase potential, which is not there. And it also has a cross phase reference with the C and B elements, therefore canceling out one of your phases. Great example. This does happen sometimes. And again, it's one of those examples where a guy can set the meter and take off because he sees that the meter's powered up and kW is positive. Therefore, the meter worm is turning. Okay. Good job. Now, the last one we're working on is going to be a 9S meter in a 6S socket. So we're going to be plugging in a 9S meter in this case. Okay. Ready, John? So,
They don't get to see if you're on the high step of the wire. I'll catch a lot of grief. Standing on one leg with the elbow touching the
Yeah.
back and forth.
all right, you're stable. All right, so John is setting it up. He's got, in the PowerMaster, he's selecting a 6S service because that's what we're simulating here. But we're simulating the idea of someone accidentally plugging in a 9S meter. Let's see what happens. Yeah, so kind of see here, I've switched this over to connection view. You can see it's kind of something similar we saw in the opposite version where we've got that BC voltage reference all jacked up. So that's what's going on here is that they've got a, you're not seeing any C phase voltage, which the 36S meter would measure it as B, and then there's no phase reference for C phase. So that's a problem. That's two problems going on, right? It's just almost in a very, very similar fashion that we had on the 9S and a 6S and a 9S service, right? Okay. So let's go check and see what the meter test runs out to be. Oh, sorry. I'll let the talent take care of that. Still good on mic?
Yeah.
Again, I apologize for us having to switch so much. So just right. So a very similar problem we had last time, right? So we see that we're again missing that C phase voltage. Once again, on the difference between the back of a 9S and 6S service or meter, I'm sorry, the phases are shifted, and that's why the service is misinterpreting that element to be a C element rather than B element. You know, I'm wondering, will that pulse?
Yes. It's always about timing, baby. Woo!
They can't hear you anyway.
Huh?
They can't hear you anyway.
I know.
Yes, they can.
Oh. Happy to be here this morning. Be part of it. What's a glove?
Yeah. I'm not touching anything hot, though.
So how's the registration going to come out, Chris?
Probably not great, because I've got a bizarre phase reference, and then I've got no B voltage. You think so? 100%. Now notice that it's taking a little bit of time to get a pulse, and that's probably easy to explain. When you have missing elements and you've got phase references, there's very little to any kW that's positive to allow the meter to turn. So therefore, that's probably why it's taking so long. Not a great meter test. Obviously, your customer would not be very happy. That's what's going on. Good scenario. I don't think this one is as common as I've seen more of the 6 in the 9S. I've seen more of those. I haven't seen as many 9S and 6S's. But it's another good example. That wraps it up.
Where do you want me?
Stay here. Talk to this guy.
Talk to that camera. Okay. First of all, thanks for all the suggestions that we got. That's what's driving and guiding this webinar, and then Tuesday's webinar. It's all suggestions from you guys, so we really appreciate it. Keep them coming. This is what this is all about. Having a chance to be very specific to your utility doesn't happen every day, so let's take advantage of it. And so if you want to, send in something you want to see, and if you want to get your team together to look at something, as I said, holler at us. We're having people take advantage of it, so you can do it too. So just let us know and holler at us, and we'll set up an appointment for you. And we set something up with just your utility to look at one specific thing if that's what you want to see. Okay? Anyway, we just really appreciate the feedback from you guys and the response. So if there's anything you want to see, please let us know. Okay? And so before I wrap it up, I'm going to pray us out of here, and hopefully we will see you guys on Tuesday. Okay? Precious Heavenly Father, thank you so much for another day for us to learn our craft, to do things safer. We were actually looking at some things here, putting meters in the wrong sockets. We know that can result in some bad incidents out there. So hopefully this helps folks because the key for us is just doing their jobs safer, Father, and that's what we want to do. Thank you for this time, the technology to do this. Thank you so much for folks that are listening to us out there, and keep them safe. And I know everyone's starting to get relaxed like we're ready to go again, and I guess we are, but I just want to keep thanking all those healthcare workers out there that put themselves in harm's way. A lot of them have been afflicted with this, Lord, and so we lift them up to you, lift this country up. We realize that the forecast looks for some volatile situations between us and other countries and us and some of our own citizens, so it's going to just watch us through this, Lord, and be with us. And most of all, thank you so much for your Son. Without him, none of this is possible. So all of this I ask and say according to the will of the one who paid it all, my brother, Jesus Christ. Amen. Thank y'all. God bless. Be careful out there.